You know that feeling? A warm, crusty loaf of bread? But have you ever really stopped to think about what's going on inside that dough? It's so much more than just a recipe. It's this incredible scientific transformation, almost like kitchen magic. So let's dive in and break it all down. Okay, so this is the big question, right? How on earth do you take something as simple as flour and water and turn it into this soft, airy, delicious loaf of bread? I mean, it seems impossible. But the answer? Well, it's all in this beautiful dance between chemistry and biology. All right, to really get this, we've got to meet the four main characters in our story. And I don't want you to think of them as just a list of ingredients, okay? Think of them as a team, a super team, really, where every single one has an absolutely critical job to do. So, first up, we've got our architect, flour. Now, inside the flour are these two really important proteins. When they get wet, they link up and create this amazing, stretchy network we call gluten. You can literally think of it as the scaffolding, the entire framework that's going to hold our bread together. And then comes water, the activator. Its whole job is to just wake everything up. It hydrates those proteins in the flour, which is what lets that gluten network even begin to form. Plus, it dissolves the salt and sugar, basically getting everything ready for the yeast to do its thing. Okay, now for the real life of the party, yeast. And this is the part that just blows my mind. Yeast is a living thing. It's a tiny, single-celled fungus, and its job is simple. It eats sugar. As it eats, it releases carbon dioxide gas, and all those little gas bubbles are exactly what makes the bread rise and gives it that light, fluffy texture we all love. And last but not least, we have salt, our regulator. You might think it's just for flavor, but oh no, it's doing so much more. It actually keeps the yeast in check so it doesn't go totally crazy and ferment too fast. And on top of that, it strengthens that gluten network we talked about, giving us a much better loaf in the end. See? Every single ingredient has a very specific job. All right, our team is assembled. Flour, water, yeast, salt, they're all here. Now it's time for the workout. We're talking about kneading. This is the part where we get physical and actually start building that crucial framework for our bread. So kneading is way more than just mixing stuff together. It's all about building that structure. You see, when the water hits the flour, those proteins start to unfold. And then, as you knead, pushing and folding, you're physically tangling them up, forcing them to link together. What you end up with is this incredible, strong, elastic net. And the whole point of all that work, all that kneading, is to find this perfect balance. You need that gluten network to be elastic, right? Strong enough to trap all the gas the yeast is about to make, but it also has to be flexible enough to expand. Think of it like a balloon. It needs to hold the air, but also be able to stretch as you blow it up. Same idea. Okay, so our structure is built. Now we just let the dough rest, or at least that's what it looks like from the outside. But inside? Oh man, inside, the yeast is just getting its party started. This is the moment, this quiet but powerful transformation where the dough really truly comes alive. So what's actually happening in there? Well, the yeast is having a feast. It's munching on all the sugars from the flour, and as it eats, it releases two really important things. First, carbon dioxide gas. That's what gets trapped by the gluten and makes the dough rise. And second, alcohol and other compounds that, well, that's where that amazing, complex bread flavor comes from. And the result? It's seriously dramatic. I mean, you start with this dense little ball of dough, and you come back after the yeast has done its job, and suddenly it's this light, airy, poofy thing that's probably doubled in size. That, right there, is the power of fermentation. Okay, we've built the structure, we've filled it with gas, now it's time for the grand finale. The oven. This is the final act. This is where all that hard work and potential gets locked in for good through this crazy, rapid-fire series of events that transforms soft dough into actual bread. And so much happens in just a few minutes. It's wild. The second the dough hits the heat, the yeast goes into this final frenzy, right? It lets out one last big burst of gas. We call that oven spring. Then, as it gets even hotter, the yeast dies off. The gluten network and starches harden up, locking that airy structure in place. And finally, that super high heat kicks off the Maillard reaction and caramelization, which is just a fancy way of saying that's what creates the gorgeous golden brown crust and that incredible smell. So let's just recap that final act real quick. The yeast gives one last puff, the structure sets like concrete, and the outside gets all brown and crispy. Boom. It's this incredibly fast, multi-stage transformation.
And there you have it. We started with just 4 simple ingredients, and now look, we have a complex, delicious loaf of bread. It feels like magic, but it's really this perfectly predictable journey. It's all guided by chemistry and biology. Every single step has a clear scientific purpose.
So, next time you're about to bite into a piece of bread, just take a second. Think about all that incredible science packed inside. Which kind of leads me to a final question for you. Now that you know everything that's going on under the hood, do you think making bread is more of a disciplined science or is it a creative art? Something to think about. Thanks for joining me.